1 and a 2 and a, oh, there it is. Got it. It says this meeting is being live streamed. Well, welcome everybody to the HealthEagle show. Here it is, the very end of March 2022, and we have had a great time. We took 2 weeks off here recently from the show in order to get ourselves together after finishing up the endocrine system. And now this week, we're into the lymphatic system, and we're going to find out what happens when your cells poop. Now, the lymphatic system is part of your immune system, or in fact, the immune system is actually part of the lymphatic system. All right, so the two are tied together, and then you'll find out later in the show how the endocrine system and the lymphatic system are also tied together in your body, making you healthy, helping you be happy. So here we go. All right, so our purpose again is to help you live happy, healthy, and more fully lives, you know, in terms of being able to do more things. And the lymphatic system is part of the immune system, as it says here. It also maintains a fluid balance and plays a role in your absorbing of fats and fat-soluble nutrients. The lymphatic system involves an extensive network of vessels that passes through almost every part of your body, all your tissues, to allow for the movement of fluid called lymph. Lymphatic system, lymph. Interesting, lymph actually means water-like. And you've probably noticed this in your body at certain points in time where you've either had a cut or a pimple or something like that. And first part that comes out when you is a clear liquid. Guess what, guys? That's lymph. And now we're going to go forward and figure out how it fits together in the rest of your body. This lymph circulates in your body in a similar way of blood. As a matter of fact, half of its cycle is in your bloodstream, but half of it is not. There are about 600 lymph nodes in your body. These nodes swell to response to infection, right? They host your T cells and your B cells. These nodes are due to a buildup of a lymph fluid, and it attacks bacteria or cleans your lymph of bacteria and organisms and immune system cells that are broken down. And it also washes your lymph after your lymph washes your cells. And I'm going to get more to that in just a minute. Samuel, welcome to the team. Glad you're here. So waste disposal, your cells generate waste, and somehow that waste needs to get out of your body. So for instance, each individual cells goes through things like microphagia and autophagia, and needs to break down, and the renewal of your cells, or the interior cells. You also generate lose a track of thought here. Your cells renew themselves. They also generate antioxidants, right? We know that from the standpoint of the teachings that we've had along the way, that in order to clear out the oxidation, you have to have the antioxidants. And in the Cell Centrals technology, it is all about causing your cells to generate their own antioxidants rather than trying to feed and take care of oxidation from the outside of the cells, where it's important, but it's more important on the inside cells, because that's usually where your cancers and the deterioration occur and the breakdown of your mitochondria. So what we want to do is be able to generate antioxidants inside the cell. Well, when you get antioxidants and they get rid of the oxidation, you have to the cell has to dispose of it. And there's a type of procedure called autophagia. So the cells collect and decompose and recycle surplus or damaged cell material. This process is known as autophagia. And it's important because the cellular waste can be harmful to your entire body if it accumulates in the cells. Like the treatment of household waste, autophagy requires certain mechanisms and elements to remove autophagy. Now, I'm going to leave this link right here. We're not going to go to this, but this kind of explains a little bit more about what is autophagia, and it'll give you a background. But if you can just think of it as that is when your cells poop, is autophagia. And these damaged cellular components are exposed to the outside of the cell. Well, what is on the outside of the cell? Well, you have a fluid-like tissue that envelops the rest of your body. You've often heard that your body is mostly water, right? Well, guess what? That water is lymph, right? And it's made up mostly of water. So don't forget to drink your water. And one of the real reasons for staying hydrated is to keep your lymph flowing. During the process of autophagia, your damaged cells are removed and the proteins and cellular waste that's accumulated in the vascular is called the autophagium. Okay, rather than how domestic waste is packed up in bins, and the waste is flushed away from the cell by the lymph in your lymphatic vessels and transported and cleansed in your lymph nodes. So what are parts of the body that are part of the organs that make up your lymphatic system? Well, your bone marrow, for one thing, because inside your bone marrow is where you're generating your immune or your T cells and your B cells, and you're going to the initiation of them. The maturation, we're going to find out more because you learned that previously in the endocrine system, where T cells are matured, right? We'll get more to that and we'll do a reminder on it. But basically, bone marrow is very, very important to your immune system and your circulatory system, because blood cells and red blood cells and white blood cells are originated out of your bone marrow. Okay, so guess what? The thymus, right? You remember your thymus here, right? Your thymus? Anybody? Yes, indeed, the thymus. It is part of your endocrine system. Guess what? It's part of your lymphatic system. And this is where you're going to see your T cells matured, inside the thymus. Your lymph nodes, they're everywhere in your body. There are over 600 of these lymph nodes. Most common ones are right underneath your chin, right here in the back of the bone here. You can oftentimes feel them when you are under attack and your lymph nodes are fighting, because this is one of the big areas, and they will get swollen up and you can actually feel them when they do get small, when they get swollen. Your spleen, your tonsils, your mucous membranes, and your skin, okay, are all part of your lymphatic system. What you're seeing here in the pictures are cells that actually help you fight off bacteria and viruses. And these are part of your lymphatic systems, all these lymphocytes. And we're going to fight off all your bacteria. So you've got various different, like a Bacillus is for fighting off allergic responses. So all of this comes together and works. And so we store T cells, we send them out, we attack things. We've got B cells, and they work inside your body to eliminate like things like cancers and viruses. All right, we're going to get more to that. The lymphatic system has three main functions. All right, it maintains the balance of fluid between the blood and tissues. Right, this is your fluid homeostasis, and you know homeostasis means life. Right, you've got that one from previous education videos, but homeostasis means life, and it also your fluid life. And oftentimes there's a misnomer in traditional Chinese, understanding traditional Chinese medicine and Western medicine in the concept of qi. Well, the chi is not the blood. The chi is your lymph. It's the blood. It's the life force that flows through your body and circulates around your cells, and it must flow in order for it to function. What we have also is the fact that the lymph, as I said, travels half of its cycle inside of your arteries, and you'll see more about that in a minute. It forms part of your body's immune system and helps defend against bacteria and other intruders. So, for instance, how do your white blood cells attack a skin-borne bacteria associated with a cut or an infection that you might be getting? Well, guess what? It doesn't travel through your blood. It travels through your lymph. Right? So take for instance, who hasn't ever had a pimple, and when they pop this pimple, out comes a little clear liquid and then the pus, right? Do you know what the pus is? Those are your dead white cells, right? They have been killed in the battle with the bacteria. Go figure, it's so cool. And then the facilitates the absorption of fats and soluble nutrients in your digestive system, okay? Half of your digestive, or 90%, 80%, whatever they using of your digestive system is part of your immune system. Well, guess what? Your immune system and your lymphatic system are like this, guys. All right? So it's all working together to make everything fit together. The system of these small vessels or lacteals, they enable the absorption of fat through the gut from the actual inside of your intestines into your bloodstream. These fats need to get into your body and help you, right? Remember, we need to have good fats. Good fats. They work with the blood capillaries, and they've folded surface membrane and small intestine, and these capillaries absorb the nutrients directly into the bloodstream. So really important component of this. Let me see if I can't get the English out of the way here. All right, that should help. Anyway, what I want to do here is to say this is an incredible system that hardly anybody knows anything about. You've got bits and pieces throughout your life, but you really don't necessarily understand it. And I want to tell you a little story here because it is so important. And one of the reasons why I chose to do the lymphatic system after the endocrine system was because I incurred some issue with my legs and this fall, and I started seeing some swelling in my legs, especially in the ankles. And when I push on the skin, right, it would leave dimples, and these dimples would last a long time. And the legs looked swollen, especially around the ankles. And I'm going, okay, well, I know that I need to do something because this isn't right. I need to learn what it is, and I need to figure out how to fix it. And you know what? Last week, while I had my legs up in the air, they sort of look like they had to do this up in the air like this. Okay, so this is my head's down here and my feet are up here. Okay, and I'm on the bed and I've got my feet up against my legs up against the wall here, right? And all of a sudden, I felt just like somebody flushed the toilet, right? It all of a sudden went, and oh my gosh, I felt so great. And in working that, I had tried so many different things. My cardiologist said, make sure that you're walking lots. And I said, well, I'm doing 10,000 steps a day, on a regular basis, sometimes more, sometimes a little less. Like yesterday, I did 9,000. And before that, I did 10,000, 7,000, that sort of thing. And on periodic, I do 23,000. So do these steps. And so keeping the legs active and so forth. They felt a little tired, right? Your legs felt a little tired and uncomfortable, and sometimes your ankles were a little sore. but it wasn't debilitating. It was just that something in my body just wasn't working right, and I needed to fix it. Well, we tried things like acupuncture for increasing the chi, improving the chi. That didn't do very much good. Guess what? And I thought I saw Samuel on board here, but Jishi started giving me.
All right.
Hello, Samuel.
I needs to come down here and tell us.
All right.
Sorry.
So
I don't know how to.
all right. So we'll get you muted there, Samuel. But I'm glad that you could come. I'm going to talk. This is a Percosa story. So we got this lymph problem going on in my legs, and Jishi starts giving me 2 tablets of Percosa in the morning and 2 tablets in the afternoon in the evening with my my health packs and other vitamins and optimizers, right? And this is when I started seeing improvement. So after a course of about a week and a half, or about a week of Percosa, we had this big change. And now my ankles are thin again. My legs are energetic, and I'm not having any more puffiness or swelling indications. So we've gotten the lymph to flow. And I'm really happy about that. At 65, it's an important component. Too many people have leg problems when they get older. They have trouble walking and so forth, and a lot of that is the case. Now, I did go through the process of making sure that it wasn't gout, but my diet doesn't lend itself towards things like gout. And then with my pulmonary embolism from last summer from the blood clot in my legs. This could have been caused by that, and the cleansing out of it, but it was not something that was associated with any of the diet. It just needed to be corrected, and apparently the correction worked out really well with an extra dosaging of Percosa. And this is one of the issues that I want to highlight again and again, is that pay attention to your dosing. The minimum dosing for your health pack is morning and night. Morning and night. That's the minimum in order to get the intended benefit of a health pack. Now, the optimizers, they have recommended dosing, right? And then you fluctuate them basically on how your body reacts to them. And as long as you're taking your health pack, the optimizers will work much better, right? So if you're looking at something, you need to get the health pack in first and then optimize out of that to get to the better health. And you pay attention to what your body does with the amount that you're taking. Okay, so you have to adjust based upon your own, but they're on the labels of each bottle, right? On the labels of each bottle of your USonic, there are recommended dosings. And if you're not attuned to what your body's doing, that start with the recommended dosing. Start with the recommended dosing, and then adjust as your body needs more or your body needs less. And we've talked about this, especially about Percosa and various different injuries that one can have that need to be repaired. I've talked about my ankles, where, if I take 4 pills 3 times a day for 3 days, my ankle twist or ankle strain is dissipated. A groin pull is 4 days at 3 tablets 3 times a day, and that's my body. Your body's going to be different, but this will give you an idea of the benefit of nutrition to acute injury. All right, so the next slide. Now, we mentioned this is that lymph is means water-like. So it looks like water. It's not exactly water. It's a lot of protein involved in lymph. So the lymphatic system consists of these lymph vessels, the ducts, the nodes, and other tissues. Lymphatic system is a network of vessels that collect these fluids or lymph. Lymph is a clear fluid that is derived from blood plasma. Around 2 liters of lymph fluid leak from your cardiovascular system into your body tissues every day. And we're going to learn more about what leak means. But basically, you have capillaries, and they have minor holes, tiny, tiny holes in them, so that the nutrients can get from the bloodstream into the cells to feed the cells. Well, this lymph actually passes through that same barrier, right, and fills up the interstitial tissues between your cells and your muscles and ligaments and all of that. That's where the fluid is, and of course into the skin. And then, so we talk about there's about 2 liters of this lymph every day. Lymphatic fluid is squeezed through the vessels using the muscles. So when you move your muscles, you're actually pushing the lymph through. It doesn't pump, so to speak, but it is pushed by your muscle contractions and relaxation. So guess what, guys? You know, I just gave you one more reason, you know, things to think about when you're thinking about your lymph is that if it ties back into your muscle contractions and muscle relaxations, what have you learned previously is that every muscle contraction eats calcium, right? And every muscle relaxation is magnesium, right? So guess what? You know, you've got to get into your Mega Cal D and make sure that you've got that as part of your health pack and your Cell Essentials routine, and to help with this lymphatic system health. Okay, lymphatic vessels have valves inside of them, okay, so that the lymph can't go backwards. So for instance, so it pushes and it opens up and it flows out, flows into the lymphatic vessel, and then is used, your muscles actually move it along, but it can't go backwards. The lymph is drained progressively towards your larger vessels until it reaches 2 main channels, which are lymphatic ducts in your trunk, right? Trunk right here, right? And then it goes up in thoracic vessel here, and then is back in. So through the whole process, it comes and washes your cells and then comes into the lymphatic vessels. They go through your lymph nodes, where they're purified, and then back into your thoracic artery, goes back into the artery, and then is pumped back out into your capillaries, and then crosses the capillary boundary and back into the lymphatic vessels. All right, so all of that leads up to this, and we're just doing an orientation on the lymphatic system, and I will talk to you more later in this program about where we go from here. All right, Mila, you want to take over here? That very first one is an excellent video.
Okay, sounds good. Let's see here, share the screen. One second, I'm setting that.
That's okay. Everybody understand that the logistics of how we got to do this is pretty complicated, and Neil and I go through this almost every week to try to make all of this happen for you, to bring these out. And I must look at like 50 or 60 videos before I select the ones that are best suited for our presentation. Given the fact that we can't watch the hour-long ones, and we certainly, got to keep them within the half hour that we allocate.
Can you see my screen?
I can see your screen, Mila.
All right, here we go.
Lymph means clear water in Latin, and it describes the fluid that flows through the lymphatic vessels and lymph nodes, which make up the lymphatic system. The three major roles of the lymphatic system, the reason we need it in the first place, are that it returns fluid from the tissues back to the heart, it helps large molecules like hormones and lipids enter the blood, and it helps with immune surveillance to keep infections from running amok. So let's take a closer look at lymph and where it comes from. The blood in the arteries is under a lot of pressure because it needs to reach every little nook and cranny of the body. Those arteries branch out into narrower and narrower arteries, and then arterioles until finally it gets to the capillaries, which have walls that are only 1 cell thick and are slightly porous. Red blood cells are too big to fit through the capillary pores, but small proteins like albumin and fluid can make it through.
During menopause, estrogen drops and cortisol rises, causing unwanted tummy fat, and running an hour a day or cutting.
Every day, 20 liters of fluid, water, and protein seep out of the capillaries and becomes part of the interstitial fluid between the cells. About 17 liters gets quickly reabsorbed back into the capillaries, but that leaves around 3 liters of fluid behind in the tissues each day. This 3 liters of fluid needs to find a way back into the blood so that the body's interstitial fluid volume and blood volume both stay constant over time. That's where the lymphatic vessels, or just lymphatics, come into play. They collect excess interstitial fluid and return it to the blood. Once the interstitial fluid is in the lymphatic vessels, it's called lymph. You might be wondering how there can be 20 liters of fluid seeping out each day if the blood volume is only 5 liters. Well, remember that the 5 liters is constantly in motion, and that it gets recycled over and over every single day. Unlike the circulatory system, the lymphatic system isn't a closed loop, because fluid and proteins make their way into the microscopic lymphatic capillaries, and all of the collected lymph is dumped into the veins. Lymphatic capillaries are the smallest lymphatic vessels, and they're located throughout the interstitial space. Lymphatic capillaries are extremely permeable because their walls are made of endothelial cells that only loosely overlap, forming one-way mini-valves. These endothelial cells are anchored to structures in the interstitial space by collagen filaments, which allows the lymphatic capillaries to stay flexible but retain their overall shape. When the pressure in the interstitial space is greater than the pressure in the lymphatic capillary, the endothelial mini-valves open up, allowing fluid to get in. When the pressure in the interstitial space is less than the pressure in the lymphatic capillary, the endothelial mini-valves are pushed shut, which keeps the lymph inside. Once that lymph is inside the lymphatic capillaries, it travels through bigger and thicker walled vessels, then trunks, and then ducts. There's no pump pushing lymph through the lymphatic system. Instead, smooth muscle in the lymph vessels reacts to the pulsing of nearby arteries by squeezing to get things started. And then the squeezing of skeletal muscles, which normally contract throughout the day, exert external pressure to keep the lymph flowing along, eventually reaching a nearby lymphatic trunk. To keep the lymph from sliding backwards, the lymphatic vessels have valves just like the veins do. The lymphatic trunks are each named after the regions of the body that they drain the lymph from. 2 lumbar trunks, 2 bronchomediastinal trunks, 2 subclavian trunks, and 2 jugular trunks, as well as 1 intestinal trunk. From there, the lymph is delivered to either the right lymphatic duct, which collects lymph from the right arm and the right side of the head and chest, or the thoracic duct, which is a lot bigger and collects lymph from the rest of the body. The right lymphatic duct dumps lymph into the junction of the right jugular vein and the right subclavian vein, and the thoracic duct dumps lymph into the same junction on the left side of the body. That particular spot is perfect because it's where the pressure is very low, which makes it easier for the lymph to flow in. The lymphatic system has key advantages. For example, it can pick up larger molecules, like hormones, that are too big to get into the capillaries, and then get them to the bloodstream. The lymphatic system can also help get nutrients to the tissues. For example, during a meal, fatty acids get packaged into balls of fat called chylomicrons by the small intestine. But just like the hormones, these are too big to move across capillaries. Instead, the chylomicrons go into special lymphatic vessels called lacteals, which get their name from the fact that the lymph that flows through them looks like milk. The chylomicrons slowly make their way up into the thoracic duct and get dumped into the venous blood. Now, the lymphatic system also plays a role in immune function. Lymphoid organs remove foreign material from the lymph to keep it from entering the bloodstream, and act as lookout points for the body's immune defenses. Some lymphoid organs are in the form of diffuse lymphoid tissue, where they're just a loose arrangement of lymphoid cells and protein, typically in the lining of the gastrointestinal and respiratory tract. Another type of lymphoid organs are lymph nodes, which are tightly packed balls of lymphoid cells and protein. Hundreds of lymph nodes cluster along the lymph vessels, each one a few millimeters to about 1 to 2 centimeters in size. When they're concentrated along the lymph trunks, you can feel them, especially in the neck, armpit, and groin. They can also be found in the intestinal wall, where they're called Peyer's patches. When an infection gets into the tissue, it can slip into a lymphatic capillary and move into a lymphatic vessel. Unfiltered lymph fluid drains into a nearby lymph node, where any pathogen or piece of a pathogen is quickly detected by a dendritic cell, which is a type of antigen-presenting cell that serves up pieces of anything it destroys to other immune cells. In the lymph nodes, dendritic cells continuously sample the lymph and present antigens that they come across to the B cells, which are a type of lymphocyte that can make antibodies. B cells are designed to only react to foreign antigens, and if the dendritic cell presents something foreign, the B cell turns into a plasma cell and starts cranking out antibodies, which then flow into the lymph and exit the lymph node. There are also circulating T cells, which are another type of lymphocyte that move between the lymph nodes, lymph, and blood, on the lookout for pathogens and infected or abnormal cells that have been tagged by antibodies. Another lymphoid organ is the spleen, which is about the size of a fist and sits on the left side of the body below the diaphragm and on top of the stomach. The spleen has both white pulp and red pulp. The white pulp is where antibody-coated bacteria are filtered out of the circulation and antibodies are generated by B cells.
This is Todd.
Hi.
This is Todd's mom.
Hi.
In a moment, Todd's mom will read her son's internet browsing history.
What?
Aloud, please.
No.
Supermodels on trampolines.com. Why don't girls like me? How to overcome an
Okay.
In a sense, the white pulp of the spleen is like a giant lymph node. Although unlike a lymph node which receives unfiltered lymphatic fluid, the spleen receives blood. The red pulp of the spleen is where old and defected blood cells are destroyed, and their parts, which are the hemoglobin, the heme chain, and the iron, are either broken down or recycled. The spleen is also helpful in that it keeps red blood cells and platelets available in case they're suddenly needed by the body. Really, it's an organ that's got your back in an emergency. Another lymphoid organ is the thymus, which is in the upper part of the chest, just below where a necklace might sit. The thymus is most active in the neonatal period and pre-adolescent years, and then slowly atrophies and gets replaced by fat after puberty. The thymus is involved in the development of T cells, making sure that any T cells that react to self-antigens, antigens that are normally found in the body, are promptly destroyed. A final set of lymphoid organs worth mentioning are the tonsils, which include the adenoid, tubal tonsils, palatine tonsils, and lingual tonsils. Together they form a ring of lymphoid tissue around the throat, and their main job is to trap pathogens from the food you eat and the air you inhale. Alright, as a quick recap. The lymphatic system refers to the one-way network of lymphatic vessels that allows lymph, which is a clear fluid that's squeezed out of the blood, to transport nutrients to cells and act as a method of waste removal. Lymph is cleansed at lymph nodes throughout the lymphatic system, which play an important role in immune function.
Hey guys, Vince here.
Here we go. So we're looking at this lymph, and one of the really interesting things that just came out is, and I put it onto Facebook, onto our page, our HealthEagle page, was about the B cells. And you know, we've technologically and medically and so forth, spent a lot of time working on T cells and their relationship inside the immune system, not really well understanding what the B cells do. And now the B cells have received experimentation and development, trying to learn more about what they do. And we're finding out that B cells play a really, really important role in eliminating cancers. So keep following this as your personal interest allows. And these B cell development could end up being keys. Oh, by the way, if you follow the history of Santa Vive Medical Center, you know that the USANA Medical Center down in Rosarito, Mexico, treats cancers with nutrition and has a much better success rate than any kind of chemo or deadly poisons used in the American medical system. Okay. And this is, interesting in the fact that what they do down there is enhancing your B cells. And they provide nutrition that is specifically entailed trying to do that. But guess what? You all, as long as you're taking your health pack and things like Percosa, are fighting and building your B cells and enhancing your lymphatic system through that process. And we'll get back to that in a minute. Okay, Mila, next one. Hello, Lynn. And Lynn?
The airport. You're waiting in line to get through security. You're in your socks, in public, and you're wrestling with those plastic bins, and people are yelling at you about dumping liquids and taking your laptop out of your bag. But even with a certain amount of chaos, the line moves pretty quickly. I mean, it should, theoretically, because really everyone has the same goal, to get to where they need to be. Now, you probably think at this point that I'm setting you up to talk about stress or anxiety or something, but I am not. Instead, I want you to imagine that security line as being like your blood, moving through your high-pressured circulatory system. And you, my friend, are not just some impatient traveler in a hurry to catch the next plane to Seattle. You are a bit of blood plasma. And the biggest concern of everyone in your queue is just to get delivered to their destination. But the problem with rushing stuff through a blood vessel or through a security line is that if it moves too fast, you run the risk that something bad might get through. So in the case of the line at the airport, every now and then, the security people funnel some random folks over to a slower line for a full pat down and a bag check. And that is kind of what your lymphatic system does. It takes up some extra fluid, and while it's ultimately helping it get to its destination, it runs a background check to make sure it's legit. It may not be as well known as some of your other more popular organ systems, but your lymphatic system quietly plays a vital supporting role to both your cardiovascular and immune systems. For one thing, it maintains your homeostasis by eventually returning most of the fluid that has been diverted back into your blood. Which is good, because if it didn't, your ankles would swell up like balloons, your lungs would fill with fluid, and your blood volume and pressure would drop to the point where your body would just give up and you would die. But the lymphatic system isn't just another security line. It also has a series of checkpoints that are staffed by special security officers that have the ability to take care of small infections on the spot. Or if they really don't like the looks of what they've found, they can alert the whole immune system to take it down. So for keeping your blood volume levels where they need to be, for keeping you from collapsing from low blood pressure, and for preventing you from dying from a staph infection every time you scrape your elbow, you have to thank the unsung hero of your anatomy, your lymphatic system. Structurally speaking, your lymphatic system consists of three main parts. The first is just your lymph. It's a watery fluid that flows through your lymphatic system. Much of your lymph starts out as blood plasma that gets forced out of your capillaries, way down in the capillary beds, where the leakage helps the exchange of nutrients and gases between the blood and the capillaries and the hungry cells in your tissues. The blood capillaries reabsorb some of the fluid, but a lot gets left behind. So much of the rest of your lymphatic system works to soak it up and get it back to where it needs to go, inspecting it along the way. For example, you have a network of lymphatic vessels that help reabsorb the fluid at about about 600 or 700 lymph nodes, which are basically checkpoints that monitor and cleanse lymph as it filters through. Then there are special lymphoid organs like the spleen, thymus, adenoids, and tonsils, as well as other lymphoid tissues throughout the body. Some of these organs and tissues house special defensive cells of the immune system to fight infection by gobbling up bacteria and other harmful antigens, all of which we'll get a lot more into in upcoming lessons. Others, like the thymus and spleen, provide a nursery for maturing immune cells called lymphocytes. But to understand the special supporting role that your lymphatic system plays in your body, let's start with its origins in the capillary beds of your circulatory system. You'll recall that these beds are where the capillaries carry blood from your arterioles and your arteries before that, and feed blood into your venules and eventually your veins. This is where the transfer of nutrients and waste takes place, as blood pressures force plasma out of the arterial end of the capillaries and into the interstitial fluid between the cells of whatever tissue you happen to be in. And most of that fluid gets drawn right back into the capillaries on the venous end thanks to osmotic pressure. But some is left behind. Of the 20 liters a day that's forced through the arteriolar end of all the capillaries all over your body, only 17 liters is taken back up by the venous end. Those other 3 liters? That becomes your lymph. It's almost immediately picked up by nearby lymphatic capillaries that wind their way in and among the blood capillaries, and they're really well suited for their job. Lymphatic capillaries are made of loosely overlapping endothelial cells that look kind of like roofing shingles, forming little flap-like valves that only open in one direction. So when the pressure in the interstitial space becomes greater than the pressure inside the lymphatic capillary, the flaps push open and take in fluid to relieve the pressure. Once the fluid is inside a lymphatic capillary, we can officially call it lymph. Then it flows through successively larger lymphatic vessels to collecting vessels and then the larger trunks, and finally into one of 2 big ducts that feed back into the lowest pressure area of the circulatory system. The right lymphatic duct drains all the lymph collected from the upper right area of the torso, as well as the right arm and the right sides of the head and thorax, and feeds them all into the internal jugular vein. The larger thoracic duct takes lymph from the rest of the body and dumps it into the subclavian vein. Overall, these vessels work a lot like your veins do. They operate under very low pressure, have a series of valves that prevent backflow, and are helped along a bit by smooth muscle in the vessel walls that keep the fluid moving. Okay, so the lymphatic system takes extra fluid that's squeezed out of the blood capillaries and basically mops it up. That sounds handy, but as a living thing that wants to stay alive, what's in it for you exactly? Well, remember, we're talking about recovering 3 liters of blood fluid per day. That's more than half your total blood volume. If that weren't returned to your circulatory system, you'd be looking at a serious drop in blood pressure and little to no oxygen delivery or waste pickup. Plus, any blockage in the lymph system, like from a tumor that obstructs one of your vessels, can be really dangerous, resulting in edema or swelling that can constrain blood flow and lead to serious complications. And finally, don't forget that your lymph also plays a key role in the function of your immune system. Say you scrape your elbow and some bad stuff, like the staphylococcus bacteria that's covering your entire body right now, infiltrates some of the loose areolar connective tissue under your skin. Since that tissue is full of interstitial fluid that drains into your lymphatics, which ultimately drain to your heart, you're gonna want to vanquish those bad guys before they have a chance to wreak any havoc. Whatever will you do? Well, this is where your lymph nodes come in. Your body's main lymphoid organs, the lymph nodes, are where your lymph gets close and regular inspection by its resident immune cells, lymphocytes. Depending on what kind of troublemaker they find in the fluid, the lymphocytes might trigger the release of resident macrophages to attack unwanted microorganisms, or they might activate the general immune system outside of the node if they need extra support. The details of how that happens we will get to next time, but for now, just understand that lymphocytes are found in and mature in the loose reticular connective tissue that makes up a large part of the nodes and most of your other lymphoid organs. Now, if a node is overwhelmed by whatever invader it's trying to quell, it may become inflamed. You can actually feel some of your nodes if you poke around the sides of your neck. They feel like little bumps. Yeah, there they are. And noticeably enlarged lymph nodes are often an early diagnostic sign of disease or infection, which is why doctors are always feeling around under your jawline during checkups. But your lymph nodes aren't the system's only checkpoints. You've also got a few special outposts placed at strategic entry points to particularly sensitive tissues, like those in the respiratory and digestive tracts. These are called mucosa-associated lymphoid tissues, or MALTs, because they can be found in mucous membranes around the body outside of the lymphatic vessels. Your tonsils are some of the largest collections of these tissues, which together form a ring around the entrance of the pharynx. There, they can inspect everything you eat and breathe and try to remove any pathogens before they enter the GI tract or lungs. It's a pretty big job, actually, which is why sore throats and swollen tonsils are a common sign of a cold or other infection. Another collection of malts called Peyer's patches are in the distal portion of the small intestine, providing another checkpoint along the GI tract. And contrary to popular myth, your appendix is not useless because it too contains a bunch of lymphoid tissue and is conveniently located where it can destroy any remaining bacteria before it can breach the intestinal wall during absorption. Exactly how your lymph and immune cells detect and destroy the unwanted visitors that might otherwise kill you is what we're going to be talking about for the remainder of this course. But for now, you learned how your unsung lymphatic system supports cardiovascular function by collecting, filtering, and returning interstitial fluid back into the bloodstream via a system of lymphatic vessels. We also talked about the system's major role in fighting off infection and how lymph nodes and other lymphoid organs and malt areas house antigen-attacking lymphocytes that provide crucial support to the immune system. Thank you to our headmaster of learning, Linnea Boyev, and thank you.
And there we go. So, nearly the same presentation, but in a different way. And hopefully you picked up a few extra pieces of in nuggets. I always like listening to this guy because he's so entertaining. And the concept of lymph now should be better understood, and we'll get a chance to go into some more of the details. The issue associated with the immune system seems to be the biggest focus of lymph analysis as we look at medical research as it has come through the 20th century into the 21st century. So we need to understand that again and again, is that there is so much that we don't understand about our own human bodies and how they come together and how we work together, that there's always something new occurring. And the release of medical papers and so forth tends to be very, very interesting from that standpoint. Next.
An overview of all the major body systems is nice, but something remarkable happens when you explore one body system at a time in a bit more depth. And, in our opinion, one of the most fascinating systems of all is the immune system. Why? Because it features cells in your body that work day and night together to protect you from a constant threat of pathogens trying to bring mayhem. And most of the time, you don't even know it. Most of the time. By pathogen, I could mean a lot of things. A lineup, viruses, bacteria, fungi, protists, parasitic worms. We could go on. Your body has external protection against these things, like your skin. We call that a first line of defense because it's the first line against letting these pathogens inside your body. Mucous membranes, too, like the lining of your nose, will keep pathogens from getting inside. This first line of defense is non-specific because it's not selective about what it blocks from getting into your body. But this is all not foolproof, and sometimes they do get in. And when they do, your immune system has all kinds of ways to deal. After all, this is not its first rodeo. So let's say they break through our first line of defense. Well, the second line of defense includes the inflammatory response. To explain it very simply, let's say you step on a sharp stick, and there's some bacteria on that stick, in your foot. The initial damage of this stick into your foot can cause certain types of cells, such as a mast cell, to react. These cells are filled with substances that work with allergic responses and inflammatory responses too. One substance that they contain is histamine. If they are triggered to release histamine, the result is that this will cause blood vessels to dilate, meaning they widen near the injury. Histamine also contributes to making these blood vessels leakier. The dilation and the leakiness of the blood vessel makes it easier for many types of white blood cells, such as certain types of macrophages, to reach the area. And macrophages do what macrophages do best. They consume the pathogens. Additionally, your body has a complement system. The complement system is not what it sounds like. It basically works to help or complement the actions of the immune system. It can work with non-specific or specific responses. In this situation, the release of complement factors, in this case, can further attract macrophages to the area to consume pathogens. When all this signaling stops, the damaged area can return to normal. the pathogen has been terminated. However, that also was a non-specific response. Who knows what was on that stick? So that takes us to the third line of defense, the specific line of defense. If you had a cold virus spreading through your body, you may need your response to be targeted on that pathogen. Now, as we give our typical notice, the immune system is very complex. We've just been giving some basics, and we're going to continue to do so. But there are a lot of extra details and exceptions that this short video can't go into. We encourage you to explore. Okay, so we mentioned, what if we need a more targeted response? We're moving into something known as adaptive immunity. Sounds fancy. This is a specific response to an antigen. An antigen is something the body recognizes as non-self, and in this case, it is something that would be a part of the pathogen. This adaptive response is going to be the third line of defense, as the first and second line of defense may not have been enough to control the pathogen. We're going to focus on the basics of two adaptive responses, cell-mediated and humoral. Cell-mediated. This involves the cytotoxic T cell. The cytotoxic T cell is a white blood cell that has the ability to destroy cells that have been infected by the pathogen. It does this by releasing signals that causes the infected cell to do apoptosis, which is a type of self-destruct. It can do this by releasing a protein called perforin, which actually causes holes in the cell membrane. This causes water and ions to flow into it and destroys the cell. When cells that have been infected by a pathogen are destroyed, this can also destroy the pathogen, or it can mean the pathogen at least can no longer replicate inside that infected cell. The thing is, for this response to work, you have to activate a cytotoxic T cell. Stimulating a cytotoxic T cell could mean an infected cell presents an antigen from the pathogen that had infected it. The infected cell presents the antigen on its own cell membrane, kind of like a little flag saying, "Hey, I've been infected, and here you go, this is what it is." This activates cytotoxic T cells to bind and release signals that causes the infected cell to perform apoptosis. But there's another way to stimulate cytotoxic T cells too. Remember how macrophages may have been consuming the pathogen? When they do, they process the pathogen, and the antigens from the pathogen are transferred to the macrophage's surface. A white blood cell called the T helper cell can bind. The macrophage will release chemical signals, which then causes the T helper cell to release chemical signals, which then can stimulate cytotoxic T cells. Cytotoxic T cells will be in search of infected cells so they can stop the pathogen, and they will also continue to amplify the immune response. That's the cell-mediated response, simplified. But remember how we mentioned those helper T cells? They're big helpers, as they help not only in the cell-mediated response, but they also help in the humoral response. So what happens in the humoral response? In one scenario, a macrophage has consumed a pathogen, and once again, has an antigen from the pathogen on its cell membrane surface. Then it binds a helper T cell. That helper T cell could also stimulate a white blood cell known as a B cell. B cells are white blood cells that have the ability to make something called antibodies. Before I define antibody, can we just take a moment and recognize that there are three words that sound very similar and can involve the immune system. Antigen, which is something that the immune system recognizes as foreign to the body. We've been mentioning that one a lot. Antibiotics are substances that can specifically destroy bacteria. We have a separate video on those. But antibodies are something totally different. Antibodies are proteins, and they tend to be in a Y shape. Antibodies have an antigen binding area where they bind a specific antigen. They will be found in blood, but many antibodies can also be found in mucus, saliva, breast milk, and more. There are different classes of antibodies. For example, IgE can protect against parasitic worms, and it's responsible for a lot of allergic reactions. Antibodies are generally very specific, so there must be an antibody that is able to bind to an antigen. When antibodies bind an antigen, they can deactivate the pathogen by affecting the ability of the pathogen to move, reproduce, or cause harm. The binding can also be like signs telling macrophages, "Here it is, come eat it." So activating B cells causes these antibodies to be produced, and this is part of the humoral response. While B cells can be activated by a T helper cell, they can also be activated by free antigens themselves that they may come in contact with. Now, we do want to mention that both in the humoral and cell-mediated response, there are memory cells. There are memory B cells and memory T cells. These cells keep a memory of the antigen they were exposed to. Memory B cells can activate plasma B cells, which will make antibodies. Memory T cells can activate cytotoxic T cells, which will go after infected cells. The ability to keep a memory is very important, and this is also where vaccines come in. Vaccines can introduce either an inactivated or very weakened pathogen. This means the body does not get the disease itself, but it will launch an immune response. By launching an immune response, there will ultimately be memory immune cells that will be involved in launching an efficient attack if that pathogen is ever encountered in the future. Overall, this immune system that you have, it's pretty incredible. There are entire giant textbooks about this topic alone, and careers dedicated to studying it. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.
Right. So the storytelling on this one is really quite good when you get to the point of trying to understand it from a basic level and get to understanding of the immune system responses. But remember that in transporting those responses, we're talking about lymph as being the transport mechanism, and that the residency of your T cells happens to be in your lymph nodes. So after you get a mature T cell developed into your body from your thymus, right, it goes reside in your body, basically in your lymph nodes, until they're activated and made to go and attack some intruder. The B cells, on the other hand, through the spleen, come into the bloodstream and then get into your lymph nodes as well, to react to various different bacteria and carcinogenics. Okay.
The lymphatic system is a multifunctional body system. Its roles include transportation of lymph and combating infection. The components of the lymphatic system include lymphatic vessels, lymph nodes, and lymphatic organs. Lymphatic vessels form an extensive network of thin-walled vessels that transport lymph around the body, eventually emptying it into the venous system. Lymphatic vessels contain numerous valves and have a beaded appearance, bulging between adjacent valves when filled with lymph. Lymph nodes are small masses of lymphatic tissues situated along the course of the superficial and deep lymphatic vessels. Their function is to filter lymph as it passes through the lymphatic system en route to the venous system. Lymphatic organs are structures that produce lymphocytes and include the spleen and the thymus gland. Lymphocytes are white blood cells which circulate in the bloodstream and lymphatic system and are concentrated in lymph nodes. They are components of the immune system and have a role in combating infection.
Very simple, just a reminder, video in a different language presentation. So going on, Amelia, let's go to the next one. And remember that a lymphocyte is a cell, either a B or a T cell.
Macroscopic mechanisms attract the T cell to navigate the vascular system and travel to the antigen-containing lymph node. The draining node expands the diameters of its arterioles by 50%, ensuring more blood will pass through. In the high endothelial venule, the vessel the T cell must extravasate through to get into the lymph node, fever increases the expression of thermosensitive molecules. Pro-inflammatory cytokines encourage the T cell to move across the high endothelial venule at the specific draining node. Once in the lymph node, the T cell faces the monumental task of finding a dendritic cell that is presenting the antigen. Microscopic mechanisms exist to help increase the odds. The dendritic cell itself has finger-like dendrites that sweep an area around the cell, sampling nearby T cells. During development, collagen fibers become encased by fibroblastic reticular cells that secrete extracellular matrix proteins to create an intricate conduit system. The conduit system increases the chances that a T cell and an antigen-presenting dendritic cell will meet up while traveling the same path. Macroscopic and microscopic mechanisms are imperative to initiate an immune response, ensuring the continual survival of the individual.
I like this presentation a lot because of the reinforcing of the issue of collagen. And you remember that we have a collagen product that's available to us, and it happens to have the collagen necessary for that connection of building around the lymphatic system, okay, the lymph ducts and lymph vessels. So that's a important component to remember is that within the inventory of products that are available to us from USANA, which we trust deeply because of the science that goes into making them and the purity that they have, is that you have what you need in order to take care of your lymphatic system, whether you knew it or not going in. Okay, Mila, next one.
The lymphatic system helps our bodies get rid of toxins, waste, and other unwanted materials, including infections and cancer cells. It is a system of thin tubes called lymph vessels and lymph nodes, or glands. These run throughout the body. The spleen, thymus, tonsils, and adenoids are also part of the lymphatic system. Along the lymph vessels are small bean-shaped lymph glands. You might be able to feel these in your neck, under your arm, and in your groin. But they are also throughout the body, including the chest, abdomen, and pelvis. The lymphatic system carries a colorless liquid called lymph. As the blood circulates around the body, fluid passes from the blood into the body tissues, carrying food to the cells. This fluid bathes the tissues to form tissue fluid, which collects waste products, bacteria, damaged cells, and cancer cells if there are any. The fluid then drains back into the lymph vessels, where it is transported towards the lymph glands. The glands then filter the lymph, taking out any harmful products. The lymph also contains lots of white blood cells, called lymphocytes, which help us fight infections. The lymph eventually reaches a large vessel at the base of the neck, called the thoracic duct, which passes the filtered lymph back into the blood circulation. If the lymph vessels or nodes are blocked, removed, or damaged, it can cause a buildup of fluid. This can cause swelling, known as lymphedema. For more information about lymphedema and cancers of the lymphatic system, go to cruk.org/cancer-types.
Oh my gosh, lymphedema, swelling of legs. Okay, so in many people where they get extremities that swell up, as I did, is that you go and look at your lymphatic system and see where your blockages are and then start treating those blockages. Right?
So David, without the video, if you want to share your screen.
Okay. I'll be going back to my screen. All right. So those were the look at the lymphatic systems and talk about it. The other aspect of this is to remember that when the lymphatic system drains from the lymphatic glands, right? Where does it go? Well, it actually has two choices. It goes through the liver and then to the kidneys and then is expelled out of the body, those waste products. So when we say what happens when your cells poop, right? Guess what? Your lymphatic system is the flushometer, right? And it takes you right out and gets rid of it through a process of filtering, killing, and then disposal. So let me get rid of this floating thing down here again. Hide the floating thing. All right. So let's go to the next slide. So the T cells, or the thymus cells, and the B cells, the bone marrow bursa-derived cells, are the major cellular components of the adaptive immune system. T cells are involved in cell-mediated immunity. T cells also use cytokines as messenger molecules to send chemical instructions to the rest of the immune system to ramp up the response. And as we know, when we talk mostly about the immune system, you're going to hear these killer cells, these T cells, and how very, very important they are. And they truly are. But I want to bring up the recent developments in medical technology that is spending more time looking at the very important service that your B cells do. And these B cells are a type of cells that produce antibodies that fight bacteria and viruses. So when we go back into getting rid of bad stuff in your body, we need to pay attention to the B cells. The B cells are important as the T cells and are much more than just the final cleanup crew. They make important molecular molecules called antibodies. These molecules trap specific invading viruses and bacteria. Without this line of defense, your body would not be able to finish fighting most infections. B cells can inhibit tumors, and this is where the most recent study that I posted dealt with is the ability to kill and remove tumors, and development through the production of tumor-reactive antibodies promoting tumor killing, or NK cells, and phagocytosis by macrophages, and priming the CD4. Okay, so what we're talking about here is the ability to eliminate tumors from your body through the use of B cells and enhancing the B cell. So when we talk about this, I wanted to, reinforce the fact that the best time to eliminate cancers from your body is when they are these disturbances inside of your cells, so that you can use your health pack and its Cell Central's technology to do that. And for the benefit of everyone, again, when we're talking about Procosa, keep in mind that Procosa is more than just an anti-inflammatory treatment that actually works where you're inflamed. It is also a Cell Central's technology. So it also does repair work in the process of eliminating the pain, suffering, and making sure that the inflammation is around your disturbed tissues is reduced. Right. So how do you keep your lymphatic system healthy? Well, guess what? Drink lots of water. We talked about how much water you're supposed to drink. Well, guess what? Drink a little bit more. And if you're not getting the right amount, go through a process of trying to increase the amount of water that you drink. If you find it difficult to drink water, it may be because your electrolytes are out of sync, right? So we do have a product for that, and that is in our electrolyte drink or a watermelon pack. You can see it says watermelon right on it because it tastes like watermelon. But the fact of the matter is this is the approach to trying to increase your ability to absorb water, because you can drink a lot of water, but does your body actually absorb it? And if your electrolytes are out of whack, your body is not going to absorb the water that you drink. Yeah, you need to eat healthy, nutritious, nutrient-rich foods, vegetables, and supplements to provide a wide range of vitamins, minerals, and nutrients. And here you have it again. We need to feed your body the right stuff, and that's what your health pack is doing right in here. You also need to get your healthy fats into your diet, and guess what? That's what your active NutriMeal Active does, getting you the right kinds of fats at the right kinds of levels to able to keep your body moving. And remember that you need to be your lymphatic system is involved in bringing those fats across the diet, your digestive tract, the lining there into the bloodstream. All right, and then you need to exercise. Aerobic and anaerobic exercise. You need to stay mobile. You need to move. Okay, you need to activate your muscles, which goes back and says, all right, well, you need that calcium and magnesium that are in so many of our products to be able to have the ability to do that. Muscle contraction, muscle relaxation, calcium, magnesium, and potassium. And we go back into that, and guess what? Your Mineral Calm has got that, and your Mega Cal D has got that capability for you. So we go back and look at that, and I'll re-emphasize the fact that these this lymph is, a lot of the lymph is associated with proteins, and we have all kinds of proteins in our body, right? But we need to have specific proteins that be able to carry things. And this collagen product is a very good way to keep your collagen levels up. All right. So your cell essentials are formulated to meet the needs of the healthy adults. Okay. And if you're not a healthy adult, then you need more. If you're a healthy adult, you need the standard set. But if you're not healthy and you need more, then take more. And then, it helps with your immune system. All right, this is basically your cell essentials in your health pack, right? Fits everything together. Your immune system, your cardiovascular system, your skin and nails, right? Your brain. I don't know about you, but I'm always concerned about the degradation that may occur over time. And I go and actively resist that, because I don't earn my income with my hands. I earn my income with my brain. And I want to be able to maintain that long term for the life of, for my own life, as well as for the life of my family. All right. So then we go through, it also helps your brain, your eyes, your cell integrity, strength of your cells, the health of your cells, the renewal of your cells, right? Helps with the nervous system, the bones and joints, the muscles and tissue, your thyroid, right? Your liver, and your metabolism and energy. One of the biggest things that comes about when people first start taking their health pack is they feel a burst of energy. Why is that? Because your mitophagia, which is your energy factor, is now receiving the nutrients that it needs in order to create the energy that your body needs in order to be more active. I remember when I first started taking USANA back in 2016, I was at 230 pounds. I didn't exercise more when I started. I didn't have the energy to. But after I started taking my USANA, I started having more energy. Guess what? I started taking the stairs. I started walking more. I started being more active, being out and doing things. And guess what? I started losing weight around 3 pounds a week. Really nice, sustainable weight loss program. And then over the course of 8 months, guess what? 65 pounds was gone. You know what? I've been on the program ever since, and I'm still off 65 pounds, right? I've not done this, right? Or done this, which so many dieters do, right? Is that what I did was I just stayed with the program, shakes and Cell Essentials. And here we are. Okay, so the combination of the vitamin, antioxidant, and the core minerals delivers results that you can actually feel. Normally, people are actually able to feel it within 1 month of taking their Cell Essentials. I did, okay? And in so doing, you will have the increase in the energy, the increase in vitality, the increase in mental acuity, and you will feel better, be more active, and you know what? Your health will improve. All right, so here we are. We're at, okay, the next HealthEagle class. Now, I want to have everybody open up. Everybody come up and open up. Let's have a conversation here.
Hey, David.